welcoming Paul Vriend to the seminar series. He's a scientific advisor in aquatic plastic pollution at the Dutch Ministry of Infrastructure and Water Quality Management, the Rijkswaterstaat, pardon my Dutch. He is part of the team that is in charge of developing a national monitoring strategy for riverine litter in the Netherlands. In this role, he is a PhD candidate at Leiden University's Institute for Environmental Sciences. His research focuses on optimizing monitoring strategies with the goal of improving data quality. This data can then be used for design and evaluation of effective strategies to reduce plastic pollution. So please, if you've got any questions, put them in the chat, or we can time for discussion at the end. And please join me in welcoming Paul Vriend to this UNA Europa seminar series.
Thank you so much for that introduction, Sarah. Great to see everyone, and feel free to turn on your camera if you're there. Would love to see your faces if you're around. And thank you so much for coming to my lecture. And I will start sharing my screen so everyone can also see what we're talking about today. Because I'll be giving a lecture on riverine litter monitoring. And before I dive into this, I want to do a little bit of a thought experiment. So before I first go to my first slides, I want you to have a bit of a picture in your head of what a river would look like. Try to imagine you being next to a river on a riverbank. You're looking right in front of you and looking for a river. What does this look like? And I hope that you have the image clear now in your head. Because for me, it kind of looks like this. You're out in nature. There is beautiful water streaming by. You can hear the birds chirping in the background, and the water is perfectly clear. And it's just a perfect place to relax. But if I then have a closer look at how some rivers in the world look like, human activities and human pressures on river systems have put a lot of stress on these kind of natural systems. So instead of this, what I imagined beforehand, you get a little bit closer to this kind of pictures. And this is a very extreme case where there is a river in the picture. You can see in the background on the right. But there's a lot of other activities happening next to it that may or may not have large effects on the river itself. And this is one of the reasons why I am in the field of study that I am, is to try to identify what the problems are with plastic pollution, how to measure accurately in the river system, in the environment, but most importantly to be able to do something about it. These data can be used to design effective policy or other reduction strategies for plastic pollution in rivers. So that's the reason why we might want to start thinking about this topic. Just to go. Oh, it's not going. There we go. Needs to go to the next one. If you then go to the index for today, what we're going to talk about, I'll first give a little bit of an introduction. Who is sitting here in front of you? Then I'll dive a little bit deeper into why we should care about plastic pollution. I'll talk a little bit about riverine litter monitoring, how that goes in practice, and what we do with it. Some of the application optimization steps that are happening within the field. And lastly, international harmonization before we go into the take-home messages. And feel free, if there's any questions at any point, just throw them in the chat and I'll try to answer them during the presentation. I think that's always easier than getting them afterwards. So if there's anything, please feel free to put them in there. All right. Who am I? My name is Paul Vriend. As I already introduced, I'm a scientific advisor on aquatic plastic pollution at Rijkswaterstaat. And Rijkswaterstaat is the executive branch of the Dutch Ministry of Infrastructure and Water Management, taking care of all the main waterways and roads in the Netherlands. And part of that is also therefore to consider the water quality in our main rivers. I do this most of my days in the week, probably about 4 days a week, and my 5th day a week. I am an external PhD candidate at Leiden University Institute of Environmental Sciences, where I do research on improving data quality in riverine plastic pollution monitoring, where I use the research I do during my normal job at Rijkswaterstaat as input for my research, and my research as input for my day-to-day job. So it's a little bit of both. And here on the right, you can see some of the things I do during the day. This is one of the measurement campaigns we recently did on a large fishing vessel where we literally went fishing for plastics floating by in the water column. So that's what I do in my daily work life. These are some of the things that I focus on normally in my research. If we look in the middle, we have the riverine litter, but we can go in a lot of different ways with that. The biggest bulk of my normal work is the manual monitoring. So figuring out ways how to measure plastics that are in rivers. And there's a whole things you should be thinking about there, but this is one of the main things we do. And some of the things we publish about that is, for example, new methods to monitor a certain type of plastic in a river system. Next to this, manual monitoring, we're also looking at trying to figure out ways to either make monitoring methods more efficient or cheaper by involving technologies, new technologies in monitoring. And that's, for example, where we look at the use case of deep learning and cameras, the combination of deep learning and cameras to start automatically counting plastics that are floating by in a river system. We can use these data that we gather with these type of monitoring to have a look at what the fundamental behavior is of plastic pollution. For example, do we see a behavior, a pattern between the amount of discharge in the river and the amount of plastic pollution floating by? Here you can see one of the things where we see a pattern between the concentration of plastic in the river system and the amount of discharge in that river system. So we try to find what is this underlying behavior so that we can start explaining why things are happening. Some of the things we do is uncertainty analysis, trying to figure out how to improve data uncertainty or reduce data uncertainty in our monitoring, and with that improve data quality. And lastly, we do modeling, where we try to put the point observations we do in a broader temporal or spatial context, trying to figure out what for the whole of the Netherlands plastic pollution is doing, or trying to figure out where we can find hotspots. Or even on a bigger scale, you can see here the paper that we published is on a global scale, trying to figure out how much plastics are, and that's both macro and microplastics, are exported by rivers to the seas annually. So there's a whole range of topics you can start thinking about, and that we also work on a day-to-day basis. That's a little bit enough about me, and now I think the most important question is, why should we care about plastic pollution? And to start off with that, I think it's good to have a little bit of a terminology before we go on in the rest of the lecture. A lot of times, plastic pollution in the environment is divided up in certain size categories, ranging all the way from nanoplastics that you can see on the left. That's everything, well, you can see the size over there, to microplastics, to mesoplastics and macroplastics. And we do this division because each of these types of plastics have a different way, have a different method of monitoring, or require a different method of monitoring. And they also have different types of effects that they can have. For example, a bigger macroplastic bag, we can have a look at, for example, strangulation of animals or clogging of hydraulic infrastructure, while the nanoplastics we're looking at what it does inside a human body or in fauna or in plants, etc. So it's different kinds of questions that you're trying to answer there. My area of expertise is on the right side, so the meso and the macroplastic side of things. But if there's any questions about the micro and nanoplastics, also feel free to ask them. I might be able to help with them because I do research on that. But I can also maybe get you in touch with some of the people that are the actual experts on it. And so now we have a little bit more about the terminology. It's also key to figure out why it is so important. That's because this human-made material, plastic pollution, or plastic, which can be a really nice material, we can use it for a lot of good use cases. But because it's disposed of in a wrong way, or it's made to emit microplastics to the environment, we get a lot of plastics all around us. And we can find it on the left top. We can find it in our soils. We find it on the right top in the Arctic. We find it on the deepest points of our ocean. And we even recently found plastics inside human brains, but also in embryos. It's everywhere. So it's at this point we're not per se looking at is it somewhere, but it is there. But what can be the effects of this? And it's quite shocking that it's already everywhere. But I think it's also key to now start understanding where it is, how it came there, and what kind of effects it can have. And these negative effects, we already have a little bit of an insight of what it can do. And I think there's a couple of major groups that we can start dividing these effects and negative effects into. And the major part, the first one is being economics effects. Here, plastic pollution can have major costs on, for example, the fishery sector, where nets may be broken, or plastic may have an impact on the fish population. But also the tourism sector, where, for example, a beach in a nice warm area where normally a lot of tourists come, suddenly is very polluted with plastic pollution. Less tourists will come to your beach and you also make less money. And lastly, if you then want to start doing something about it, it also costs a lot of money to start cleaning up the plastic pollution. Some interesting thing also might be like, oh, I never really go to the beach, or it doesn't really affect me. But it also has shown that plastic pollution, bigger plastic items or litter, can actually affect a lot of things. For example, housing prices in your neighborhood, those kind of things also are included in these economic effects. Next up, there's a whole scala of environmental effects. Some of the major ones I've put here on the slide. There's some major effects on animals, for example, strangulation or ingestion by animals. Here on the right top, you can see a seagull trying to do something with a plastic ice cream container. But you also see that a lot of birds, fish, and also bigger mammals, we find that they have plastics in their stomach. And we never know exactly if the animals that we find on beaches, for example, have specifically died of the plastics, or that they were ill and started ingesting because they couldn't catch any other food. But we do find quite a lot of animals that have quite a lot of plastics in their stomach. And that is quite worrisome, especially as the plastic can enter our food cycle, and therefore also end up in our food, in our body. And that's interesting to see what that does. Maybe it's really bad. We don't know exactly yet. What we also see is that there can be increased flood risk, where hydraulic infrastructure gets blocked by plastic particles. And you can see an example of that in the left bottom, where a test was done with plastic items in hydraulic or flood hydraulic infrastructure in Indonesia. And we had a flood happening or occurring when normally there would have been a flood if the plastic wouldn't have been there. And there's a reduced water quality, both by the plastics that are in there, both the microplastics, but also the microplastics breaking down into the smaller plastics, the microplastics and the nanoplastics. But also because of the additives that are added to the plastics leaching into the water, and those can also have impacts on the water quality and everything that's in the water. And then lastly, there's a possible implication on human health. And I say possible because the direct link is not a very hard or concrete one yet, but we do see that microplastics are almost everywhere or are frequently found in human body in all kinds of locations. And we're now at the start of trying to figure out what the effects are of these particles on our body. What we already see, for example, in plants is that plants can take up microplastics, and that can impact root growth, for example. So now this is all the beginning of the research. So it might still increase in the knowledge we have about these human impacts. But from the precautionary principle, we can already say we really need to do something about this. And the possible effects are mostly the smaller items, but the biggest source of these smaller particles are the larger plastics. They can break down under stress they experience in the environment or by UV radiation into microplastics. So even if we now stopped emitting microplastics and macroplastics in general, there's still a huge wave of microplastics that will, or the concentration environment will still increase a lot, because the current particles that are in there will only break down and become more and more microplastic. So even if we stop the tap right now, we still have quite a lot of work ahead of us to do something about it in the environment. So now we know a little bit on why we should care about this. I'll also go a little bit into more detail about how we start gathering data on this environmental pollutant. And what is important to know there is that in the environment, in the riverine environment, plastics can reside in a lot of different compartments of that river. And here we have a couple of examples of that. For example, plastics can be deposited on the riverbanks. It can be tangled up in plants or trees up on the floodplains. It can be floating on top of the river system. It can be suspended in the water column. It could be either bed transport or bed deposition. And also biota can ingest these plastics. And to get a full understanding of what is happening, or what the plastic budget is in a river system, in an ideal world, you would start monitoring all these compartments. Luckily or sadly enough, we're not in an ideal world. So mostly we need to make decisions on what kind of compartments you will start monitoring. And for now, what is mostly done is the floating plastics are being monitored. The plastics on the riverbanks are being monitored, and we're starting to monitor plastics in the water column as well. But it's quite early in that. So the first insights are coming in on that, but there's still a lot of progress to be made there. Then the question was that we had at the Dutch government is, how do you go from zero monitoring in a river system to eventually a long-term national monitoring strategy? And that's where we were asked to come up with a roadmap to try to figure out how do we go from 0 to 100% of what we do, and make sure that the monitoring also fits with the research questions that we have, or the monitoring questions that we have. And for that we came up with this. It's a little bit a lot to take in right now. So I think it's the most important to just have a look on the left. There's 3 major steps that it should be taken. We should first have a method to start measuring plastics in a certain river compartment. You then, step 2, start adopt this monitoring method to your local circumstances and your research goals that you have. So you start coming up, for example, with the frequency, you start monitoring the spatial scope, spatial extent, the temporal scope, and with that you can then come up with the first monitoring guidelines, and you do a first baseline assessment with that to try to figure out, does my monitoring strategy work? Do I need to make some changes? Do I need to make something better? And then once you've got that, you can then start the long-term monitoring. And then on the right of this figure, you can also see each of these 3 steps has a certain type of question you can already start answering. And that is good to know when you start monitoring, to figure out, okay, where do I start? But for the Dutch government, we have decided that we made it a little bit easier for ourselves. So we decided to start monitoring 3 compartments in the river system. And then it's in Dutch, so I'll go through it in English as well. We chose 3 different compartments, those being the riverbanks, in Dutch called de oever, the floating plastics, in Dutch drijvend, and the plastic suspended in the water column, that being waterkolom in Dutch. In that, you see the 3 steps here. So developing a measuring technique, then doing a first baseline assessment, and then starting the long-term monitoring. And then in the end, we also decided there's an extra layer to it where we have things that do not really fit in these 3 steps, but do need to be taken care of. So for example, the data storage in the right way, so it's all the metadata is there and people can actually start using these data, but also the project with the technology, we also put it in there. And so we've now been, for the past 3 to 4 years, we've been going through these 3 steps to try to figure out, to try to start developing this method, this monitoring strategy. If we then have a look at each of these compartments, what I will do now is I'll just have a brief overview of what kind of methods are used for each of the compartments that we use in the Netherlands, what the pros are, what the cons are, what some of the things are that we can start using these data for. And also, in the end, I'll come down to a little bit of technology, how they can be involved with this method. So I'll start with the floating litter. And for the floating litter, we use the visual observation method. And this is where we go on a point of elevation above a river, mostly bridges, as you can see on the right. And we start manually counting how many items of plastic items are floating by. And normally you could either do this on a small bridge with one person, but normally in the Netherlands the bridges are quite a lot wider. So we then start dividing the bridge up in sub-segments, and that's where people start counting each segment. And you then extrapolate the whole river width and start extrapolating this to the time that you're interested in, or the temporal scale that you're interested in. And this is a pretty low-tech method, but it gets the job done quite well. It's been applied all across the globe, in the European Union, in Asia and Africa. And it's often preferred because it's cheap and flexible in its use, and it requires little training. You can be fully trained to apply this method within an hour or two. And you can actually start gathering data, which is already very, very useful. And this method gives insight in the flux, so how many items are floating by per time unit. The temporal and spatial variation, so how does the transport in the river change over the year, but also in the river width. And also it gives a little bit of an insight of the composition of the litter that is floating by, because we also note down what materials are floating by. What we do in the Netherlands, we have started this method in 2022, and we have 12 observations per year at 10 locations in the Rhine, the Meuse, and the IJssel. Those are the major rivers here in the Netherlands, where the Meuse is the one here in the bottom, flowing here to the west, that comes in from Belgium. The Rhine starts here, comes in from Germany, and goes all the way to the west. And the IJssel is a subsidiary of the Rhine, and it flows here in Lake IJssel in the north. And since we have monthly observations since 2022, we can then start having a look, okay, how does this change over the year? What is the effect of the discharge? Those are the kind of questions we can start to answer. And also, hopefully, in a couple of years, what are trends over time? Because hopefully, with the things that the Dutch government are doing in order to reduce litter in the environment, we'd hopefully see those effects also in our monitoring data. So yeah, that was one of the first things we started doing here in the Netherlands. But we also now are starting to dabble a little bit into technology, where we hopefully can start replacing these manual observations, so the people standing on the bridge, with cameras, and then start counting the plastics that are floating by with AI or deep learning, in order to automate it and be able to increase the time that you are actually monitoring. With this, the potential is there to start continuously monitoring during daylight. During nighttime, it's a little bit difficult to use RGB cameras to count these plastics. And it's also possible to use these cameras in locations where there's no bridge available, for example, by using drones. And this would be interesting, for example, in places where there's no bridges available, such as in the estuary system in the Netherlands, where the bridges are far and far between. So yeah, it would be nice to start using that. But we do note that there's still some substantial steps required to have this applied at the operational scale, in both the technical sense, but also legislative sense, in order to get all the occasions you need to install a camera on the bridge. Takes quite a significant input to do that. I'll move on to the riverbank litter. And this is a really important one, because what we see in a river system is that only a small fraction of the plastics are actually in transport, but most of it is actually deposited most of the time on riverbanks. And what we do here is we use a protocol developed originally to monitor plastics on beaches, and we have adapted it so we can actually use it on riverbanks. What we do here is we set out a sampling area of 100 meters by 25 meters. And we have two field workers go through this area, and they pick up everything they can see. And then they start categorizing all the items that they find according to the OSPAR category list, which is a list with about 130 different categories on it. So you can both say something about how many items or what's the concentration of the items that we find in the riverbank. But also you can then start saying things about what is the actual composition, can we link the items that we found to certain sources, etc. And it's really important, for example, to have a direct test if you want to see if your policy that you took to, for example, reduce the amount of plastic bottles in your environment, you can actually see, do we see a downward trend in plastic bottles in our riverbanks? Again, this is a method that's often used because it's cheap, flexible, and requires little training. Again, this can be, someone can be up and running in about an hour of training. And the nice thing is it gives both insights in the accumulation and composition, and also when you do this often enough in the trends over time. And again, hopefully that is showing a negative trend. If we then move on to how we do that in the Netherlands, we've been monitoring riverbank plastics since 2022, and we do this with a frequency of 4 observations per year. At a total of 50 locations along the rivers Rhine, Meuse, and IJssel. Those are the same rivers I just mentioned, but we also now have the Western Scheldt. That's the estuary here on the left, on the bottom left of the Netherlands, where we also have 10 extra monitoring locations. That is also because it's an interesting and important location to monitor. Like I said, all the litter gets picked up and categorized, and with that we can actually have quite a nice database. And since it's very similar to the monitoring method used for beach litter, we can also start comparing what we find in rivers compared to what we find on beaches. So that's a really nice overlap we do there. Then I'll move on to litter in the water column, so everything that's suspended below the water surface. And this is a little bit less developed, where for the first 2 methods we already have a method or strategy where we have the locations, the frequency, and exact protocol. For here we're still testing quite a lot of different nets. We have so far tested 3 types of nets, those being nets that are normally used for larvae research, trawl nets, which are mostly used for fish research. So for example, fish and they are mostly used for shrimp, for example, in the Netherlands. And stow nets, which are normally also used for fish research, but are a little bit bigger, and the mesh size or the holes in the net are bigger compared to the trawl nets. All techniques are still in development, but as the Dutch government, we've decided to choose the trawl nets as the net that we're going to use as for our monitoring strategy. And what we already see, we've tested quite a lot of locations, and we're currently in the process of coming up with the whole protocol. But what we already see from our measurements is that a significant share of the litter transport occurs below the surface. And it can be multiple orders of magnitude difference compared to, or higher compared to, the floating plastics. And this technique will give insights in the flux, the composition, and the temporal and spatial distribution again. So that's a whole broad set of insights we get from these measurements. And again, here we're also, I have a nice video of what we do. Here you can see the boat that we use for these net measurements, and you can see the nets on the side. And those nets are 4 meters wide, 1 meter tall, and 10 meters long. And the mesh size, so the holes in the net, are about half a centimeter. So exactly the border between, or the threshold between, micro and mesoplastics. And here you can see on the left there is a net that's at the river surface, and then on the right you can see 2 buoys, and they signify that there's a net halfway in the middle of the water column. And we can also, if we want, hang a net all the way at the bottom. So we can have 3 different depths where we can start measuring and start having a look at the horizontal and vertical distribution of plastics in the water column. But this boat is normally used for fish research, but now we're also using it for fishing for plastics. And this is a video that was captured all the way upstream in the Meuse River, very close to the Belgian border, where we did some measuring campaign. Then we'll move on to the next slide. There we go. Also for the water column, we are developing methods to make the manual monitoring with the nets, to replace that with maybe something that is a little bit less labor intensive. And for this, we have been doing tests and pilots with using sonar to detect plastics that are suspended in the water column. And here on the right, you can see on the monitor the data you get from the sonar/ADCP. And on the right top, a little bit blurry because of the picture, that is a boat that had the sonar attached to it. And then we had plastic suspended in the water column, and then when the boat went over it, you could actually see the plastic going by. This is very much at the starting point of research, but there's promising results so far. And it would be great to just be able to hang a lot of these sensors at strategically chosen locations in the Netherlands, and then not have to use nets anymore, but just use these instead. But that will take a while before we get there. Okay, now that I've shown you a little bit of what we do and what kind of measurements we do, I think it will also be nice to have a little bit of a look of what we do with these data, what is the application, and how do we optimize these data. And those are all topics that I do research on the daily. So it's pretty interesting to finally also show something that we can do with these data. And the first application of our monitoring data, and I think also one of the most important one, is to use these data to design informed and tailor-made policy aimed at reducing litter in our environment. And these data can be used in two ways. On the first way, it can be used to identify which items or areas policy should be focused on in order to reduce plastic or litter effectively. So before you actually start doing something with policy, you can say, well, oh, what are the most important things should we start focusing on? And then once these policy measures are taken, the data can be used to evaluate if the policy was effective or whether change should be made in order to make them more effective. And some examples of Dutch policy are, for example, the Single-Use Product Directive, where we can see already a reduction of the SUP items that we find. What we also saw recently is that small plastic bottles, so smaller than ½ liter, recently got a deposit scheme added to them, and you can then start looking, or do we see the effects of that in our data? But also, these data will be needed in the EU Water or Marine Framework Directive, where goals are set, for example, within the Marine Framework Directive, that we want to see a substantial decrease in plastics on our riverbanks. Then you need data to back up and to see if you're reaching your goals. And on the right is a really recent one. That is a newspaper article from last week, where you see these hygienic wipes or wet wipes or however you want to call them. They're made out of plastic and they're often flushed down the toilet. And normally most of the water that goes into the sewage system goes to water treatment facilities and gets cleaned. But at places where there's a lot of water in the sewage system, where, for example, through high intensity rainfall events, the sewage system gets overloaded and the water gets flushed down into the river without filtration. And that's where a lot of these wet wipes come into the river system. And with climate change, we don't expect more and more of these dumpings to take place, because the rain will be more intense in the future and will be more frequent. So that's where our government is now trying to have a ban on these wipes when they have plastics in them. And with all these questions, with all these use cases for these data, it's always the question: what data quality do I need in order to fulfill the requirements that I have to able to identify or evaluate policy? And secondly, we use these data in models. And the important thing here is that we use the monitoring data in models to provide a broader spatial and temporal scope, and provide insights on a broader spatial and temporal scope. Because we have quite a lot of locations. For the riverbanks, 50, and for the floating plastics we have 10. But it is not a full coverage for the whole of the Netherlands. And what you might want to know is where the hotspots are, or where large sources are, or big sources of plastics into the environment can be identified. And that's what we use the modeling for. So both in how it is transported, the flux, but also the accumulation we're interested in with these models. And there are several types of modeling that we do. We have very simple mass balances where we try to combine all the data we have from different compartments in order to get an idea of how much plastics are where. For example, what big of a percentage is on the riverbanks, how much is being transported in the water column, etc. We can also have a look at the large-scale models where we are mainly interested in how much is approximately transported to the oceans. And you can also start having a look at 2D or 3D particle tracking, where you use a model to figure out if I release a particle at one point, where will it, and with that you can hopefully identify hotspots. An example of one of the models you can see on the right, where we try to make a mass balance for parts of the rivers in the Netherlands where we have enough data to make these kind of things. And yeah, that's where you can first insight, for example, in the beginning, what I said is that most of the plastic that we find on the riverbanks compared to the plastics that are in transport. But yeah, you can, for example, also imagine that with higher discharge events or with floods even, that all the items that are on the riverbanks, they get remobilized again and therefore also start flushing down the river. And also here is again the question for the use case that I have, what is the data quality I need? What are some of the requirements that I have in there? So that's always a question that is always looming over your data or over your use cases. And then lastly, the application to figure out fundamental behavior. And this is where we try to use our data to figure out what are some of the rules that plastics follow when they are being transported through a river system. For example, one of the big questions is the litter flux correlated to discharge? And it was assumed to be so, but the more research we do, the more difficult it becomes, the more complex it becomes to really have that correlation there. And for example, we're also interested in what processes govern the horizontal distribution of litter in the water column. Is that, for example, the floating capacity of an item, or is it the turbulence in the river system, or is it the combination of both? That's sort of some of the things we're figuring out. And what's also a really interesting thing is what is the role of the estuary? Because what we see in the estuary is that there's changing tides, it's a tidal system, and therefore the flow also changes around with every cycle. And what we see that the plastics enter the estuary system, but a lot of them are retained in the estuary and don't really go to the sea. So then we can start thinking about, okay, how do we start measuring that? How do we start quantifying the netto export to sea? Those are some of the big questions we see. And right here we can see one of the papers where we try to figure out if there's a correlation between discharge and flux. And for floating, it's mostly no. And what we see in the water column, so below the water surface, is that there is a correlation between discharge and the concentration of plastics that we find, where the concentration increases with increased discharge, leading to a significantly higher transport of plastics during high discharge events. So yeah. And then we can also start thinking about optimization. And this is where, for all these use cases, we need to ensure proper data quality. But we also always need to take in consideration that we don't have an unlimited budget for these kind of measurements. So we need to find a balance between how much effort are you putting into your monitoring to reach your data quality that you're required, but not to overspend on monitoring for plastics and rivers. And in that, there's also, again, 3 steps. It's most important to identify what are your needs. So what is the data going to be, are the data going to be used for? Then we need to quantify the uncertainties introduced through design choices. So for example, what if I start monitoring 20 times a year instead of 10 times per year? Or what if when I'm on a bridge, instead of counting for 20 minutes, I increase it to an hour? What kind of effect does that have on our uncertainties in our data? And then through those insights, through quantifying these uncertainties, you can then start optimizing your monitoring strategy, where you can actually make informed decisions on how long am I going to measure, where I'm going to measure, how frequently, etc. So some of the things already mentioned that you can optimize are, for example, the sampling frequency, observation length, the sample size requirements, which is interesting. So how many items do I need to sample in a river system to say something representative about the composition or about the quantities of this very heterogeneous group of pollutants in your river system. And lastly, for example, the size of your sampling area. And you can see an example on the right where we did a test. All the way on the left is the sampling area we use currently, so 25 meters by 100 meters along the river system, along the river. And then after that, we used different kind of smaller sampling areas to try to figure out what's the effect of that. So we sampled items on the riverbank in 5 by 5 meter cells. For each cell, we could note how many items are in there, and then you can start using Monte Carlo simulation to figure out, okay, what if I subsample? How much does the uncertainty increase with that? And those kind of analyses are essential to have a good and fit monitoring strategy in the end. Okay, and then lastly, the last topic I want to discuss today is international harmonization, and I think that's often stated in the literature. And that's because riverine litter and riverine pollution in general is a transboundary problem, and the problem there is that pollution can be emitted to a river system upstream, but can cause will travel downstream and therefore will cause problems downstream for someone that might have not caused the pollution in the first place. Hotspots, for example, may occur way further downstream from a source than you would expect. So it's important to gather data in a standardized way, so that, for example, in a country upstream gathers data with the similar protocol to the downstream, so we start comparing and also see, okay, what is the input from one country, what's the input from the other country, can we start working together on this to do something about it. And once you have these data, you can actually enable proper accountability, so where are the sources and how can we tackle those, and also start doing accurate trend estimates over the whole river system. I think that is key. And we've only recently started monitoring riverine litter. I think 2016 was the first ever study in the Dutch river system where they actually properly started measuring microplastics. So we've only recently started, and it's now really starting to speed up this harmonization process. And this harmonization can happen at a couple of different temporal or spatial scales. I think all of them are important. For example, we can have a bilateral harmonization where, for example, the Dutch government is in conversation with the Belgian government or the German government to make sure that, hey, we both have rivers that we share. Let's at least monitor these in the same way, so we can actually start comparing these data. Then we also have a regional scale where, for example, at the regional sea convention level scale, of which OSPAR is one for the Northeast Atlantic, we're starting to see if we can come up with common monitoring protocols / indicators where all the countries that are in this convention start at least monitoring in the same way. And this is also an opportunity for river commissions to do the same. At European level, there's a cooperation, what we now see, between the different regional sea conventions. So, for example, the regional sea conventions for the Northeast Atlantic is cooperating with, for example, the Mediterranean and the Black Sea to try to figure out, can we start monitoring our rivers in the same way? But also there's a working group on litter at the EU level. So on different levels, there's talks on that. And on the world scale, there's now a big negotiating happening at the United Nations Environmental Program, where they're drafting a binding treaty on plastic pollution. And I think that monitoring is also there a key part, a key role in that treaty, because without monitoring data, you cannot really see if the measures you take are effective. So yeah, it's key to provide these insights across borders, because it is a cross-border problem, and it's great that these processes are going on. And for example, here on the right, you can see one of the recent meetings in Valencia, where all the European regional sea conventions came together to discuss on how they can actually monitor in the same way, in the same method. So yeah, with that, I've come to my take-home messages for this lecture. And I think there's a couple of things that you should be taking home. One is riverine litter pollution is a pressing issue of global concern, with all the negative effects that I showed in the beginning and the omnipresence of the plastics in our environment. I think it's key to at least have it in the back of your mind, and also to keep a focus on developments on possible effects it might have on the human in the future. High quality data, monitoring data are crucial in tackling this issue, for example, for policy design, but also to figure out the fundamental behavior. Lastly, that litter can reside in these different river compartments, and this makes monitoring complex. So you always need to make sure that there's plenty of data, and you can start connecting data to actually start understanding what is happening with these plastic items in your river system. And for example, on the right here, you can see some of the items that we find in the riverbanks in the Netherlands, and they mostly are a lot of degraded items that we don't really know what they are anymore. But you can also see a lot of items that are pretty recognizable, from a football to drink cans to those kind of items that you find. And with that, I would like to thank you very much for your time and for listening. And open to any questions, and also feel free to send me a message on my email if there's any more questions afterwards. So thank you very much.
Thank you, Paul. That was really interesting. I liked especially your discussion about data quality and uncertainty, which I don't think's mentioned enough in environmental data. Okay, we've got a question already from Julian. Go ahead.
Hi, can you hear me?
Yeah.
Yeah, great. Sorry, I'm on a mobile unit. I'm just traveling. Very nice talk. I have one or two questions, but just the first one I was going to ask is, what's the most common item of litter that you find in the rivers?
In a river system in the Netherlands, it is unidentifiable item, and those are mostly foils. That makes up about 50% of what we find.
Like a food packaging foil or something?
Probably, yeah. And then if it's identifiable items, I must admit, cigarette butts are up there, and a lot of consumer waste, what we find in river systems, and those can be food packaging, drinks, candy wrapping, that kind of stuff.
The standard litter stuff. So the question I have is, and I might have missed it. Someone was texting me at the same time. Did you mention sediment, and do you monitor sediment, and do you look at sediment as a sink for macroplastics, mesoplastics, and is it short term, long term?
Yeah. We try to make sure that there's a lot of connection between our litter and sediment people. But we see that a lot of assumptions that we make with sediment do not always hold for plastics, because plastics is a collective term for a lot of different items with different buoyancy, different sizes, etc. But we do take into consideration, and we'll soon start pilots with actually sampling plastics in the riverbed, in the sediment. What is interesting, though, what we can say from our microplastic monitoring colleagues at the government, is that they find a very strong correlation between suspended particulates, so suspended sediment floating by, and the microplastics are in it. So if you know the suspended particulate, you also know the concentrations of microplastics in Dutch river systems. And that's a really interesting thing, because as a Dutch government, we've been monitoring sediment transport or suspended particulate transport for the past 40 years, I think. We also have a lot of samples from them from dating back all those time. So we can start having a look, okay, what are the transport per year from all the way back in the day. We see that this pattern holds across the Netherlands at different locations, both downstream and upstream. So it's pretty interesting to note.
So to some extent, you expect that once you start looking at sediment, you'll see a relationship between what's in sediment and what's floating.
Yeah. On the smaller scale, the microplastic scale, I expect it 100% for sure. And for the larger, I don't want to make big statements about it yet, because we have assumption on it, and sometimes it works out, and sometimes it's completely different.
Because I was going to say, I mean, I think larger fragments, they would sink, but foils and wrappers may have a tendency to stay floating.
Yeah. That's what we see. And then with higher turbulence, we see that the vertical distribution becomes more homogeneous. That there's not that many difference between the upper layer, middle lower layer, and lower layer.
And in the same way, I think part of that question I was going to ask is, you mentioned the riverbank monitoring, and you collect what's on the surface, but I did wonder if you look, the 0 to 5 centimeter below the surface as well.
Yeah. The net measurements we do with the boat that I showed in the video.
No, but on the riverbank.
Oh, the riverbank. The top 5 centimeter only thing that we monitor there is the mesoplastic, so the smaller particles. That's where we take a smaller, I think it's a 1 by 1 meter quadrant, and we scoop up the top layer and see that.
So you do go, you go deeper.
Yeah.
And just one question, you mentioned concentration of plastic. So when you're doing this work, is it number concentration or is it a mass concentration? Like what do you report? What do you measure?
Yeah, it depends on the method you're using. So for the microplastic part, we have a mass concentration, so plastic per suspended particulate. For the floating macroplastic particles, we use a flux per hour, so item per hour unit. For the riverbanks,
the floating ones? Is that just you say something like, I counted 10 pieces in an hour floating by?
That's exactly what's happening there. Yeah.
Okay.
And it seems very, very rudimentary, but it does. It gets the job done.
No, it's fine. It's fine. And they are floating and floating fast. It's I think Winnie the Pooh had that as a game where they throw sticks on one tonic. But do you ever, for the stuff that you catch in your trawl nets, I mean, do you weigh those? Is that a mass you're aiming for as well that's in flux?
Yeah. We have for the suspended items in the water column, we have the concentration item count, concentration in mass, and concentration in area, because every item also gets a 2D scan. So you also say something about area, because we think that due to fragmentation, items might be there might be more items downstream and upstream, but maybe in area or mass it might be the same. But due to breaking down of particles, it's just more particles than.
Exactly. I mean, as you go downstream, the count should increase.
Yeah.
Assuming they get older. And maybe the last question, but I might ask another while I think about things.
Feel free.
You mentioned, of course, international, and you want to make sure you have the same methods, but you guys have been monitoring with a certain method for quite a period of time, and obviously you don't want to throw that out. And because Germany or the Netherlands or Belgium say something like, this is our method. So, I mean, the riverbank monitoring maybe is standard now, I assume, but is what you're doing already international? Is everyone doing the same thing? Or is there some subset that's comparable?
Yeah, in a most rudimentary way, things are being done similar. So you go to a riverbank and you set out an area and you start sampling them. But then the details, so how big is your sampling area? How do you count? How do you categorize? Those are still different. But we do see that now that there's a couple of bigger projects happening that people are, like I would say, people don't want to reinvent the wheel. If someone else has done it or doing it in the right way, you can better copy it and make it better for yourself than start a whole new. So there's a kind of overlap. So what I expect on an international scale is that there's more going to be ironing out the details, or then it's going to be a real new method that's going to come for such a large scale.
I think it's one of the trickiest ones is, what mesh size you're using on your net versus what mesh size they're using on another net. And you said, we have the cutoff size between meso and micro, but of course, it can be a skinny, long fragment that's macro that fits through your anyway.
Yeah, and what we also see, we catch a lot of organic material and a lot of microplastic items or that are smaller than our mesh size. They stick to the organic material and then you still catch them. So that's it's not that, in that regard, it's not the most exact science, I believe, but it gets the job done. It's very practical. That's what I like about this.
No, I have the same. been doing some microplastic work for a while, and
nice. Yeah.
It's it's a new frontier in many ways.
Yeah. No, I totally agree with that. Yeah.
Okay. Anyway, I'll stop.
Thank you very much for your questions.
Thanks.
So that's really interesting.
Thank you. Simone had a comment in the chat. I don't know if you had time to read it. She just said there's a new paper by Damstel 2005 that speaks to the relationship between flow and macroplastics, I'm going to guess, counts and develops a new unit of measurement. I don't know if you want to say anything else, a question, or no,
I've noted at least down.
Fantastic. I don't know if there's time for one more question, if anyone's got any burning questions. I mean, can I ask a really quick question? I know we're running out of time.
Sure,
I was really interested in your high-tech monitoring techniques, especially for the floating plastics and the suspended ones. I just wondered if there's any that look at riverbed plastics. I know it's much a harder way to count it, but could you use drones and AI deep learning modeling to count these? Has it been tried?
Yeah, we've done pilots with monitoring plastics on riverbanks with drones. There's two issues we run into. Is that one, there's no one that is really training a model on it yet, because there's less riverbanks than people that want to monitor floating plastics. So people are first starting on that, and the second thing is that there's a lot of regulatory limits to where you can actually use drones in the Netherlands. And especially around rivers, there's a lot of off-limit restricted areas. So getting the permits to actually start flying there is also kind of a major process to get through that. So it's on our backlog, but it's not our main focus right now. But it does work. We have seen that it's beautiful. We have really cool orthophotic photos of kilometers of riverbank. It's really cool stuff, but it's not on our priority list at the moment.
Yeah, because I can imagine it's quite tedious to go through a quadrat on a riverbank, pick out all the little bits of plastic and measure them. So just interested to know if there was new technologies coming up. No, fantastic. Thank you so much. I'm sure people can email you if you've got any more questions, but thank you so much for the time. I mean, I'm presenting next week, so a week on Thursday, the 27th. I'm also talking about water quality monitoring, because I think it follows on really nicely, focusing less on plastics, more on traditional contaminants in water. So look forward to seeing those of you who can make it, and I will put this presentation on the website as well. So thank you so much.
Thank you. Have a nice day, everyone.